And that is a segue to the next presenter, Piet Hoekstra, who is a professor in our faculty, has been a dean and is also associated with the Wadden Academy. And Piet will now reflect on both presentations and stir up the discussion for in the breakout rooms and long afterwards, I hope. And Piet, I would like you to start sharing the screen and go ahead.
Anyway, thanks Iris and Kelly for a very nice presentation. I think it's also very complementary to each other, highlighting different aspects of marshes in that sense. And I'd like to focus on some topics in my presentation to, everybody has the screen now?
Yes, perfect.
Okay, then we will continue. So I'd like to focus it a bit on the marshes from a coastal system perspective. I think the aspect has already been mentioned before by Iris, by telling that we're dealing with open systems as we're dealing with coast, so there's an interaction with other parts of the coast. And that's especially an element I like to introduce now also in this last section, on this last presentation, as a reflection on the theme. I've chosen a couple of topics. First of all, I'd like to give you a small glimpse of what we know about actually coastal defense, the function of coastal defense in relation to marshes in the Netherlands, and particularly focusing on the Wadden Sea system, but also with some information that is being derived actually in the southwestern part, in the Delta area. And then actually continue with the trend that we can see in the Netherlands, that people are really thinking about developing foreland marshes to protect the coast. And in that particular issue, we see actually seaward strategies and landward strategies, and I'd like to start with some general considerations about these policies, especially touching, for example, on the aspect of sediment availability, and then further continue with the seaward strategy and the landward strategy, and then conclude with some final remarks. But let's first start with the marshes as wave absorbers and flood fighters. And this is work which has been done by Vincent Fuik, published in 2019. And this is showing a part of the coast of Groningen. And you see the section of the map on the left-hand side, and you see the section of the measurement site on the right-hand side. And what he has been doing, he has been comparing a site where marshes were available and a site where no marshes were present in front of a sea dike. And what you can see in the diagram, if you compare the area in the left compared to the area in the right, you can see that there's much more wave dissipation in the left-hand section. As you can see, the waves are getting smaller and smaller due to two reasons, of course. It's the roughness of the marsh itself, but also the accretion that takes place over there. And you see a lot less dissipation taking place in the right-hand side of the figure. And that also results in a difference in the wave run-up along the dikes. And the idea is here that especially the combination of the marshes with the dikes, which could be very efficient in protecting your coast. And of course, along many of these mainland coasts, we have these dike systems present. So this combination of marshes with dikes is probably a good alternative for maybe just increasing your dike, your width or your height. He has been also very active in modeling. I think that's also something we should mention over here. There's a lot of measurement information available, and Iris already showed the information from the flumes. But of course, when we are talking about design perspectives, you also need to have tools to look at the design of marshes, in a sense, how effective marshes can be in wave dissipation. And this is a comparison where, with the wave model, he has been making a comparison of the amount of wave dissipation in percentages. Again, a left-hand figure is for a situation with a bare foreshore, and the right-hand figure shows a situation with the vegetated foreshore. And along the horizontal axis, you see the width of the area, and along the vertical axis, the depth on the foreshore. And what already was mentioned, of course, the water depth is an important parameter, especially during severe storms when your water levels are rising quite rapidly, especially in the Wadden Sea, where you have surges coming in and where your water levels are well above your average tidal levels. So this is an important factor. But you can clearly see over here, if you compare both diagrams, that these foreshores are indeed very effective in reducing the wave energy, and especially when they become wider, they can be very effective in reducing the amount of wave energy that actually reaches the dike. And there's also, of course, a seasonal component to it. This is not a picture from the Wadden Sea, but this is a picture from Zealand, where he has been doing research as well. And what it shows over a period of a couple of months, quite a couple of months, starting in the month of November in 2014 and continuing to May 2016. And what you see here, depending on the incoming wave height, the wave height reduction, again in percentages, and of course it fluctuates over the year. And that's probably something else that we have to take into account, that vegetation, of course, is different in different periods of the year, at least if we talk about temperate climate zones, where the vegetation is growing in the growing season. Of course, when you have the end of the winter, your vegetation is less active. That's quite clear. And that, of course, makes it also different from, example, the tropics, where you have mangroves, which act as a protection, but they are, of course, perennial and they are continuously available. So this was some information about the wave dissipation that may occur, but there is some other interesting information coming up, and it was published just recently, and it was done by a colleague from the Netherlands Institute of Sea Research in Ierseke, and they published a study where they had been looking at historical information. They had been looking at the effects of a Christmas storm in 1717, and been looking at also the North Sea storm disaster of 1953. And looking at all kinds of historical information, old maps, old written information in documents, they actually observed two important issues. First of all, it was clear that in those areas where you have salt marshes, that there was a reduced number of dike breachings, and also the total width of these dike breachings was smaller than in areas where the salt marsh was absent. So in a way, it's not only a wave absorber in that sense, but you can also in that way reduce the floodings, the amount of floodings and degree of flooding. And that was the second observation. The breaches that developed when dikes failed, they were less deep if you have salt marshes in front of your dike compared to a situation where this dike was absent. And of course, when your breaches are less deep, that means less water can flow into your polders behind your dikes, and it reduces then your inundation depth. So in that way, you can also reduce the damage if a flood eventually occurs. So this was a very interesting information, I think. So it is not only showing that in a single storm there is an effect, but also in case something goes wrong, the salt marshes still have a function and still are able to reduce the damage to some extent. And the combination of probably of salt marshes and engineered structures, as dikes are, is probably very efficient in coastal protection, and it was recognized by several people and institutions in the Netherlands. And I do think we do see a trend that there is a trend in developing foreland marshes now for coastal protection, and people are developing pilot projects for that purpose, for example, to see how actually we can use these marshes to protect our, or to make in combination with our dikes, a very efficient coastal protection system. And there actually is a new project in the National Science Agenda of the Netherlands. It's called Living Dikes, in which vegetation and salt marshes will be used in combination with dikes to study the impact on coastal safety. However, if we look at salt marshes, and referring back to the open system that was already mentioned by Iris, of course we have to realize that salt marshes are part of a larger system, and they will interact with their environment. So we cannot separate, especially not on the long run. And if we're talking about on the long run, if we talk about sea level rise, for example, we really have to take into account that salt marshes are a part of a tidal basins in which we have channels and shoals, in which we have tidal inlets, and in which at the seaward end we have this barrier island. But if we look at the Dutch case in the Wadden coast, we do have to deal with what we call coastal squeeze. And I'll show you a picture later on after this, what happened in the past. So what are our boundary conditions actually if we talk about salt marsh development, both from a natural point of view, but also from an anthropogenic point of view? And do we have enough accommodation space for fine grained sediment? I mean, are the energy conditions low enough to create the settling of fine grained suspended matter in this environment? And another question which has already been raised, if you want to develop, or if you want to create, or if you want to stimulate salt marsh development, you need sediment. And do we have enough sediment available to actually encourage natural accretion but also encourage accretion in case we try to step up with anthropogenic measures. Well, this is of course the reality in the Netherlands, in the northern part of the Netherlands, where we have an enormous number of indictments, and we actually lost a lot of our wetlands, a lot of our marshes, due to a long history of building polders, making dikes, and in this way actually transforming our wetlands, transforming our marshes into polders, into agricultural land. So we have been operating in a way that we did what we call coastal squeeze. We actually reduced the size of the Wadden Sea extensively. Of course, the barrier islands are still in place and they're kept in place, but over a period of many centuries, we have been actually moving in the seaward direction with our indictments and changed the system substantially. And of course, you could argue in some cases, is there enough space? Is there enough availability to actually promote salt marsh development, or are some areas better to stimulate salt marsh development than others? And one of the points, of course, is what are the energy conditions that are available within the system? And this is work from Jasper Donker in the past, in which he looked at the wave conditions, for example, in the Wadden Sea. And then we have to really conclude that the Western Wadden Sea is quite different from what we see in the Eastern Wadden Sea. In this picture is shown the wave orbital velocities of the 95 percentile. And it clearly shows that the Western Wadden Sea is a lot more energetic due to its exposure, of course, on southwestern winds, but also due to its large aerial extent. And it may be quite difficult for fine-grained sediment to settle over here. Whereas in the Eastern Wadden Sea, as you can see, the conditions are less energetic, and you may have more stimulating environments to actually promote the position of sediment. And this is more or less illustrated also. This is work in progress, which is carried out by Deltares at the moment to look at the mud balance of the entire Wadden Sea. So not only dealing with the Netherlands, but also with Germany and Denmark. And it clearly shows, for example, that in large part of the Western Wadden Sea, the mud is not actually deposited along the Afsluitdijk, for example, but usually in areas which are still adapting to the morphological change due to the building of the Afsluitdijk. So you see former channels are being filled up. As you can see, for example, in the southwest part of the area, where you have this brownish area with a longitudinal structure. These are all channels that actually cut off by the Afsluitdijk and were as remnants in the system and have been intercepting all this fine mud in the system. So that means that it may not be easy in other areas to actually encourage salt marsh development. And that brings me to the question that was raised by Iris again. Do we actually have enough sediment available in some areas for salt marsh development? And probably we have to think about this issue if we talk about the Wadden Sea system, because we are very much dependent in our mud supply. And I mean, a lot of of course, the higher part of the marshes is basically fine-grained sediment. We are very much dependent on what happens in the southwestern North Sea. We have two major sources of fine-grained sediment. That's the English East Coast, and that's the coast of Norfolk, where the cliff coast, which is what you can see in the upper left corner, where cliff erosion is an important source for sediment. And you see actually the plume, which is extending from the coast of England towards the northeast. And there is another kind of plume, which is actually coming from the Strait of Dover and the Belgian coastal waters, which brings sediment along our Dutch coast. And the Dutch coast, and it's transported on the Dutch coast and further east towards the German and to the Danish coast. But if we look at the numbers, it appears probably that it is not an unlimited supply what we have available. It might be that this is a kind of limitation to some extent, and that we have to realize also that if we start extracting sediment, or if we are extracting sediment in the system, which is taking place at some place, it may of course also affect the entire budget of the area, but it may also affect our neighbors in a way. And how this will develop in the future, of course, is quite a question. How will this supply of mud from the southwestern North Sea, how will this change in time when climate changes, when sea level rise changes? How will it affect, for example, the amount of erosion of the seabed is taking place over there? And will it result in the same kind of a longshore transport pattern that we see and that we suppose is present here along this Wadden coast? those are questions, I think, that are also relevant in the long run for the supply of fine-grained sediment to these salt marshes. Kelly mentioned the nice example, I think, of the case study of Ameland, in which he showed that the present rates of sea level rise due to subsidence are in the order of about 7 millimeters per year. And then again, this sediment availability issue is, I think, very important for the interpretation of the information, because this basin that the area was located in, that Kelly was looking at, is actually the area which is encircled here with the red dots, but it's also the adjacent basin, especially the east tip of Ameland, where this core of this subsidence area is located, does have at the moment a accretion rate in this basin of about 6.5 millimeters per year. So very close to the 7 millimeters per year that Kelly was mentioning. So maybe the developments of Ameland are still a bit positive if we compare that to the amount of sediment which is available. And that in normal conditions, if we go a bit further to the west, for example, where less sediment is available, but still the accretion rates are higher than sea level rise rates. But we seem to be in Ameland still in a kind of positive situation to look at this case study where the subsidence is actually dominating the picture at the moment. And if this sediment supply is becoming less in the future, then I think the entire picture may change in that sense. Okay, the seaward options. There are plans, of course, in certain areas to encourage salt marsh development, either in areas that are already, where salt marsh is already present, or in areas where salt marsh are not yet present. And then there will be kind of, well, a bit similar to the land reclamation works, but then a probably more creative way to create accretion. But we probably have to realize that there may be a trade-off with developments in the entire basin. If you increase the surface area of your salt marshes, and if you increase the vertical growth of these salt marshes, of course it reduces the surface area and your volume of your tidal basin, and it will reduce your tidal prism. And this tidal prism is quite a vital component if you look at the dynamics of the tidal channels and the building up of intertidal shoals. So the change in tidal prism, and particularly in relation to the wave regime in a certain area, that may result in, for example, a infilling of channels and erosion of intertidal shoals. And of course, we have this case of the Eastern Scheldt where this is happening, and where this causes severe problems. So the question actually is there a kind of trade-off between salt marsh development on the one hand and the existence of intertidal shoals in the Wadden Sea? And if we are looking at salt marsh development, are we careful enough, and are we taking these aspects into account if we look at the development of these areas? There's another problem probably. If we have the infilling of channels through a reduction in tidal prism, it may also give a feedback in relation to the tidal motion, in terms of propagation of tidal wave, but also in terms of amplitude. And again, in the Eastern Scheldt, we saw that the decrease in tidal amplitude also increased the amount of wave attack, because if you have a large tidal range, or wave energy is spread over a larger area in the vertical, and if you reduce your tidal amplitude, the wave energy will be concentrated on a smaller part of the coastal profile. And this brings me to the illustration of this phenomena. So we have seen since the building of the storm surge barrier in the Eastern Scheldt that we saw a considerable reduction in the basin area. We saw a reduction in tidal range, and in combination the two result in a reduction of tidal prism. And this has resulted for quite some time for a steady decrease of your intertidal shoals in this area. That's visible on the left-hand side, pictures starting in 1989, surveys from Rijkswaterstaat, showing that there is a gradual lowering of the shoals and a loss of intertidal shoal area in this Eastern Scheldt. And nowadays, nourishments are necessary to maintain the proper levels of these shoals for all kinds of ecological functions. On the right-hand side, we do see the effect of the reduced tidal range. If you change your tidal range in the system, your wave attack will increase over a smaller part of the coastal profile, which will stimulate the development of cliff marsh cliffs actually that we see developing here, for example, near St. Anneland in the southwestern part of one of the side branches of the Eastern Scheldt. So here we have to be careful what we do, I think. The landward option is an option which is increasingly discussed in the Netherlands, and which people are discussing the principle of what we call the double dikes, with the connection with the sea. It is clear that this may have less impact on the tidal environment, but of course this has a huge impact on the agricultural activity and the communities in these areas and the socio-economic system. And we have to realize that these options, of course, also are already in an environment where agriculture is facing a lot of problems. We have salinity intrusion in the area, which has become worse in the recent dry summers. The salt water is already at shallow depths, and we have sea level rise. So there is definitely a problem with agriculture over there. So there may be some potential for whistlepolders. I'll show you now in a few minutes the idea behind this, to actually encourage nature and aquaculture, partly to replace agriculture, but maybe also as a kind of shifting cultivation system in agriculture. One of the questions that remains, is this resulting then in more attractive inland marshes compared to foreland marshes? Well, I think Iris already raised the question that the experiments that they started in 1995 in Essex, I think it was, in the UK, do show that it's the development of these areas that in the past were agricultural land, and that to transform them in marshes that will take a lot of time and probably will not give the quality of marshes they actually like to see. And the quality of marshes, of course, this is to illustrate the double dike system. This is an experiment which is presently going on in the Eems-Dollard estuary on the northeast part of the Dutch Wadden Sea, where they have made actually a system where part of it will be used for aquaculture. That's on the left-hand figure, that's a conceptual model. And you see in the right-hand figure, you see nature development, and on the photograph on the right, you see the development of the area. So this is a real one-to-one pilot experiment taking place where they're looking at the nature development in this area. And of course, I'm very curious how this will develop over time. And if we really get the quality of the marshes we would like to see in this Wadden Sea area. The idea in those areas is also to use those areas maybe as whistlepolders. That means that in the present situation, this is agricultural land, but by letting in the seawater and by encouraging deposition, you may have the situation in which the bed level will rise due to deposition, and then at a certain stage, in a later stage, you could go back to agricultural land. But of course, the question is whether we'll have the time to do so, given the rated sea level rise that will evidently will develop in the future. If your sea level rise is increasing, then we will have difficulty probably going back to this scenario of agriculture in these areas. In all those cases, I think it's very important that we realize it's not only about quantity, but it's also about quality. And I think this is nicely showing the areas that I find very attractive from a morphological point of view, but it's probably also very interesting from a biological and biodiversity point of view. The Slufter on the left-hand side in Texel, St. Anneland in Zeeland on the right-hand side, you have natural channels, you have meandering channels, you have the dynamics of these channels. And with all the measures you take as humans, it's often very difficult to beat nature in that sense. And we should be aware of the existing systems and make sure that those systems can develop properly over time and realize the limitations we have as humans in building those systems. That brings me to some final remarks. I think we can conclude that salt marshes can be very effective in reducing wave energy and also probably limiting flood damage. Yeah? I'm a bit careful over here because the examples that were shown were from Zeeland province, and I have no evidence for this from the Wadden Sea coast actually. These marshes are clearly important habitats for the Wadden Sea and its OUV. That stands for Outstanding Universal Values. It's actually the criteria that UNESCO uses to make it a World Heritage Site. But we think we should be clear and focus on both quality and quantity of marshes. And that means especially on focusing on geo and biodiversity and also the ecological functioning of the system. I think, and that's very difficult to create if you are developing a man-made marsh, or at least it may take a lot of time before it happens. And it would be nice that if people are developing, are thinking about these policies, that they should be part of an integral approach and also consider cumulative effects, since salt marshes are simply part of a tidal basin. In the case of the Wadden Sea, they have their own history, they have their dynamics and feedbacks, and we should be careful. If we are creating one system, we should not throw away another system. It should be there probably are trade-offs in the system, and we should be aware of that. And of course, the other issue is this sediment availability. In the present system, we don't have problems, but in the future, it may be that it's even more difficult to have this enough fine-grained sediment to stimulate this salt marsh development in the future. And by that, I think I'll hand over the floor again to Martin.
Yes, fantastic. Thank you very much. If you unshare the screen, I would briefly give the floor for 2 quick questions by Kelly and Iris, and then we'll move out to the breakout sessions. Right. So Iris, go ahead. If you have a question too, Piet.
Yes, I have, but I don't think it's quick. Piet, thank you very much. I really, really enjoyed that. I wondered whether you have been thinking, as I have done, about the impact of COVID on our attitudes towards the natural environment, and whether you think there is anything that will stay and outlast COVID in our approach towards restoring nature at the coast.
Well, I think you could argue in 2 directions, to be honest. I think the COVID crisis has learned that we can enjoy our own environment a lot better than just traveling across the entire globe. So people are becoming more sensitive about their own environment, I think. But that may also, to some extent, promote these kind of projects, which may not always be well designed or well thought about. I guess it may help us in conservation of these areas and development of the areas, but to some extent it may also promote developments that probably we don't fancy too much, to be honest.
Thank you.
One thing that will stay is that we will have the Brunings lecture for international audiences, and not only in the physical sense. I'm very happy that people are joining, but apart from that, yes. Okay, Kelly, if you have any questions.
Yes, I was I was actually wondering, in the Ems estuary, currently there are quite a lot of pilots trying to actually reduce the amount of sediment. Do you actually think how does this impact the sediment budget in the Wadden Sea itself, like for the future as well?
Well, as far as I've seen the pilot projects, they are on such a small scale that the entire amount of extraction is probably relatively small in this area. And of course, you're in the situation where dominantly your transport is from west to east in the Wadden Sea, if you talk about mud. So you had more or less the downgrade side, you could say. So it will probably more affect the neighbors, Germany in this case, than it will affect the Dutch system. But it's not, I mean, all those small bits, of course, are adding up. And there is a quite a long tradition already in Germany where they extract mud from harbors, for example, and put it on land to make the agricultural land more fertile. And this can be quite large amounts that are taking place. So it's the total sum of activities which we have no control about, of course, and we know not about. I mean, this was the first time actually that somebody, and it was I think it was Albert Oost, for example, thought about this, that we needed a kind of mud balance for this system, because we're always used to thinking about sand balances and the availability of sand for morphological change, if sea level rise is occurring. But mud is often a bit neglected and overlooked, I think. And this was the first time that this idea was developed to look at this mud balance. And it clearly shows that we do have a limitation in terms of supply coming from the southern North Sea. And we knew this a bit because in the past we had this fantastic idea about building an airport in the North Sea. And then people were already concerned about the impact on the mud transport, because mud is not only important of building nature, of course, of building morphology, but it's also important for the ecological system in terms of nutrients and so on. So it has a more widespread effect on the coastal system in that sense.
Thank you.
Right. Excellent. Fantastic. I would like to thank all three speakers of this afternoon for their excellent contributions. We won't applaud you because that will produce awful noise in the microphone, but consider the applause given by the entire audience. I'm now going to forward all of you to the breakout rooms, where each and every speaker plus several other interesting people will be hosting the channel. So go wherever you like. There's the email sent to your email box with all the individual channels. Go and join and ask people questions about all the issues discussed today. Thank you very much for joining this general plenary session, and I hope to see all of you and your friends and family and colleagues next year in the Brunings lecture. And with that, I close the general session. Thank you very much.
Martin, thank you for organizing this very interesting session.
It was my great pleasure.
Thank you.